Hello, students. This is Saxon Algebra 2, Lesson 40, which is entitled Abstract Fractional Equations. Abstract generally means all variables, no numbers, but you might see numbers now and then. But it always means the answer will not be a numeric value. The answer will be an expression for the variable you are solving for. That expression will be made up of the other variables that are in the abstract equation. We assume that no combination of the variables in an abstract equation will result in zero. Multiplying them or adding them together is not going to result in zero. And this is because your solution may have a denominator, and we can't have a zero in the denominator. Finally, the problem will always tell you what variable to solve for. So without further ado, let's solve some abstract equations. The first example is a divided by x plus m divided by a equals c, and the instructions are to solve for x. Abstract equations really test your algebra skills. You just do the same thing with these variables as you would do if they were numbers. We need a common denominator. The common denominator is going to be xa, so I'm going to have a squared plus mx divided by xa equals c. I'm going to multiply both sides by xa, and that gives me a squared plus mx equals cxa. Now I'm solving for x, so I've got to get x on both sides. So I'm going to subtract mx from both sides, and that's going to give me a squared equals cxa minus mx. I can factor the right side, x times ca minus m, and that's equal to a squared. And now we see, I'm going to switch sides of the equality. X equals a squared divided by ca minus m. That's the kind of expression you can expect for your solution to an abstract equation, particularly an abstract fractional equation. We solved for x. We now have an expression for x. Okay, let's tackle example number 2. Solve for m. Again, we need a common denominator on the left side. So we're going to have x plus cm divided by m equals y divided by a. We have a proportion, which is two fractions set equal to each other, and so we can cross multiply. A times x plus cm equals ym. Now we're solving for m, so we've got to get this m on the same side as this m, so we need to do the distribution. ax plus acm equals ym. And then I'm going to move acm to the other side of the equation and end up with ax equals ym minus acm. Now we can factor m out of the right side. That equals m times y minus ac. And again, I'm going to flip it. And so finally, m equals ax divided by y minus ac. We found an expression for m in terms of ax, y, and c, all the other variables in that abstract expression. All right, let's tackle the last one, number 6. 6 divided by p. There's a number in there for you. 6 divided by p minus ax equals m divided by y plus k. And we are now to solve for p. Start out the same. We've got to have common denominator, 6 minus pax divided by p. And we need a common denominator on both sides, equals m plus ky divided by y. And now we have a proportion, so we can cross multiply y times 6 minus pax equals p times m plus ky. Now we've got p on both sides of the equation, so we're going to need to do both distributions this time. And I'm going to put the 6 first because that's the convention. 6y minus paxy equals pm plus pky. Then I need to add this term that has p in it to both sides of the equation. Which only leaves 6y on this side of the equation, but that equals pm plus pky plus paxy. Once again, factor out the p, because that's what we're solving for. That's what we want an expression for. Sorry that my table shakes. And so it's p times m plus ky plus axy, that's equal to 6y. And so when we divide both sides by m plus ky plus axy, we have our value for p in terms of all the other variables and the token number that they put into example 3 for us. So I hope this video helps you master this material, and I hope you can work through the practice problems, and I'll see you next time.